So I'm starting with a certain mass, I end up with a certain mass, and I'm going to do some calculations to figure out what that tells me, some information about my original sample. So what's happening here is I'm adding a sample that has some Cl in it, some chloride ions, and an unknown metal cation. So some metal with a positive, could be a +1 or a +2, and some Cl minus. I don't know what the formula is. I don't know how many Cl minuses there are per each metal, or how many metals there are per Cl minus. But I'm going to add that to, so that's going to be aqueous. I'm going to add that to silver nitrate, aqueous. And they're telling me that the silver chloride is going to precipitate. And the metal, whatever it is going to stay in solution with the NO3. They're telling me that I collect 1.5615 grams in the end, and that I started with 0.8633 grams of this. And then they want me to determine the percent Cl in the compound. So if I'm looking for a percent a mass or composition of this compound, I want to know the mass of the Cl in the compound divided by the total mass times 100. Right? That's the percent mass formula. I know the total mass of the compound, that's given to me. So I just need to know what's the mass of the Cl part of that. So I need a little bit more space here. How do I figure out the grams of Cl that are present in this thing originally? Well, gravimetrically, what that means is all of the Cl I started with is captured by the silver in forming a solid. So I know the mass of that. So this 1.5615 grams is the mass of the silver and the chloride. So I need a conversion to figure out how much of that is just the chloride. Right? So how many grams of chloride do I have if I start with in that 1.5615 grams of AgCl? This is like so many conversions we've done. I have information about a substance, AgCl. I want information about different substance or just part of that substance. So I need that relationship. It's going to be a mole relationship between one substance and another substance, so I've got to convert to moles first. So if I want to convert to moles first, I would get the molar mass of AgCl. So silver is 107.8682. Add a chloride, 35.4527, and I get 143.3209 grams per mole. The formula tells me that there's 1 Ag for every 1 Cl. So for every mole of AgCl, there's only 1 mole of chlorine ions in there. And then I want grams, so I'll take that 1 mole of Cl ions and convert it to grams, which is 35.4527 grams of Cl. So that's going to cancel here. here, here. Got the unit I want. So I plug that all into my calculator and I get 0.386. I've got 5 sig figs, so I need 2 more, 2.6 grams. So that's the mass of just the chloride, so I can put that here. So the mass of the chloride part of it divided by the total mass times 100 is going to give me the percent of that that's chlorine. And it'll be 44.74. Questions about that? Yeah, so that's a good point. So the CL that I got here is the CL that was here, right? Because I started with the amount of solid precipitate that formed. Figure out how much of that solid that formed was the CL. Then I'm assuming that this CL that was present here must have been all the CL that was here. So this should be, I'm following the law of conservation of matter. So I'm not creating or destroying any CL. So any CL that's there in the end must have been there to begin with. So the mass or quantity of CL minus that I end up with should be the same as the quantity of CL that I started with. I mean, that's assuming that all the CL ends up as part of that solid and that there's no CL minus ions stray around in solution. So that might not be completely correct because this solid may have some solubility in water and it may break up to produce some ions in solution that are free floating. So if I just look at the mass of the solid AgCl, that might not account for all the Cl minus in solution, but given what I know about the solubility of AgCl, it's not very soluble in water at all. So pretty much for practical purposes, all the Cl minus should be present there in the form of the solid, so I can assume that that was all the Cl minus I started with.